Hello, and welcome back to STEM Passions YouTube channel. Today, we're going to do a physics experiment about the acceleration of gravity. So let's break down what that means. Acceleration is when velocity changes. For our experiment, you can consider that as the object moving slower or faster, but that's not the only way an object can accelerate. Gravity is the force of the Earth pulling down on each object. So the acceleration of gravity is how objects speed up when they fall to the ground. For example, if you were skydiving, you would be moving faster when you were near the ground than right after you jump. That is, if you ignore the parachute slowing you down. Physics says that the acceleration of gravity is negative 9.8 meters per second squared. But how do they know this? This experiment will show us how physicists determine that number. The materials for this experiment are 2 balls of any kind, a tape measure, and a stopwatch. You can also use a stopwatch app on a phone or any other electronic device. So let's get to the experiment. To start, put a tape measure against a wall and put a piece of tape or a sticker at whatever height the experiment will call for. Next, we're going to drop each ball from that height and time how long it takes to hit the ground. Let me give you an example. I already put that blue sticker at 3 feet high, and I'm going to drop this basketball from that height and start the stopwatch at the same time I let the ball go. I need to watch carefully and stop it right when I see the ball hit the ground. Let's try it out. Here, I have my tape, ball, and stopwatch all ready for the experiment. It might be a little hard to see, but that took 0.44 seconds. Now, let's look at what to do with our data. We need to start with the equation delta y equals v initial times time plus 1/2 acceleration times time squared. Let's break this equation down. Delta y is one variable, and the triangle here, which stands for delta, represents change. So this is telling us that the variable stands for change in y, or the change in vertical distance. Next, we have v initial. This is the velocity of the ball right when it's dropped, and in this scenario, v initial is going to be equal to 0. The t here stands for time, and the a stands for acceleration. Since we're trying to find acceleration, our first step should be to make the rest of the equation equal to it. We already said that v initial equals 0, so this first term is canceled out. We're left with delta y equals 1/2 acceleration times time squared. Let's multiply both sides by 2 to get 2 delta y equals acceleration times time squared. Lastly, let's divide both sides by time squared to get 2 delta y over time squared equals acceleration. With our data, we know the values of delta y and time. Before we start solving, we need to convert the vertical distance from feet to meters because acceleration is in meters per second squared. 3 feet is equivalent to 0.91 meters. So, delta y is negative 0.91 and time is 0.43 seconds. So let's plug that into our equation. After solving, we find that acceleration equals negative 9.84. The answer isn't exactly negative 9.8, but it's pretty close. This is okay because we're not accounting for air resistance in our problem. Air resistance is a force that pushes up on the object as it falls, but we're not including it in today's experiment. All experiments also have percent errors, which tell us how much we're off from the expected number. In addition, there can be any reasons for the discrepancy other than air resistance, like human error, if the times we hit the stopwatch weren't exact. These reasons are called sources of error. Now, let's try the same experiment with a different height and different ball. The height is now 4 feet, and we will be using a baseball instead. It might be a little hard to see, but it says 0.52 seconds. This time, our vertical distance is 4 feet, which is equivalent to 1.22 meters. So, delta y is negative 1.22, and time is 0.52. We already have our equation set up from before. 2 delta y over time squared equals acceleration. Let's plug in delta y and time and solve. We find that acceleration equals negative 9.04. Again, this number isn't exact, and it's a lot more off than the last trial, but remember that we're not accounting for air resistance, and there may be other sources of error as well, so it's okay. Now, you guys can try this experiment on your own at home. Remember that it's okay if your number isn't exactly negative 9.8, but think about some sources of error that could have caused the difference. That's all for today's video. Thanks for watching!